Hi, I am Dalchan. I am introducing about advantage of managing highly connected data using Neo4j database. So in this session, we will go on the following points: NoSQL databases, graph databases, Neo4j toolchain, and Java Core API. Now, I am introducing about NoSQL databases. So what is the NoSQL databases? NoSQL NoSQL is a set of concepts that allows the rapid and efficient processing of data sets with a focus on performance, reliability, and agility. So in another words, we can say that NoSQL is literally a combination of two words, that is No and SQL. The implication is that NoSQL is a technology or a product that counters SQL. The creator and early adopters of the wizards like NoSQL probably wanted to say no RDBMS or no relational, but were infatuated by the nicer sounding NoSQL and stuck to it. In due course, some have proposed non-relational as an alternative to NoSQL. A few other things have tried to salvage the original term by proposing that NoSQL is actually an acronym that expanded to not only SQL. Whatever the literal meaning, NoSQL is used today as an umbrella term for all databases and data stores that do not follow the popular and well-established RDBMS principles. So, NoSQL database comes in a variety of shape and functionality. NoSQL is a generic term used to refer to any data store. NoSQL is not a database. It is not even type of database. In fact, it is a term used to filter out a set of databases out of the ecosystem. So that does not follow the traditional RDBMS model. Especially the data is non-relational and it does not use SQL as the query language. Another thing is it doesn't exclude SQL or RDBMS system rights. So it seems like a broad definition rights. That is not a mistake. What important is that we identify the core themes behind NoSQL, what it is, and most importantly, what it is not. So in the next, so what is the NoSQL? I'm defining NoSQL on the following terms like it is more than row in a tables. NoSQL system store and retrieve data from many formats like key value stores, graph databases, column families store, document store. It is free of joins. NoSQL system allow you to extract your data using simple interfaces without joins. Another thing is it's schema free. NoSQL system allow you to drag and drop your data into a folder and then query it without creating an entity relational model. It works on many processors. NoSQL system allow you to store your database on multiple processors and maintain high speed performance. It uses shared nothing commodity computers. NoSQL system leverage low cost commodity processors that have separate RAM and disk. It supports linear scalability. When you add more processors, you get a consistent increase in performance. It's innovative. NoSQL offers option to a single way of storing, retrieving, and manipulating data. NoSQL supports have an inclusive attitude about NoSQL and recognize SQL solution as viable options. So to the NoSQL community, NoSQL means not only SQL. Here some list of NoSQL databases like document store work on the technology like MongoDB, CouchDB, RavenDB. In the same way, key value store work on the following technology like Redis, Membase, Voldemort, MemoCacheDB. In the same way, XML follow these databases and column follow in these, and graph databases follow the Neo4j and FlogDB databases. So NoSQL databases is divided into four categories like document store, key value store, column oriented, and graph database. Now another thing is, what is the need of NoSQL graph database? Looking at what we have explored so far, does it mean that we should look at NoSQL only when we start reaching the problems of scale? NoSQL database have a lot more to offer than just solving the problem of scale. So schemaless data representation. This provides the schemaless data representation. Almost all NoSQL implementation offer schemaless data representation. This means that you don't have to think too far ahead to define a structure, and you can continue to evolve over time, including adding new fields or even nesting the data. Development time. I have heard a story about reduced development time because one doesn't have to deal with complex SQL queries. Do you remember the join query that you wrote to collect the data across multiple tables to create your final view? Another thing is speed. Even with the small amount of data that you have, if you can deliver in milliseconds rather than hundreds of milliseconds, especially over mobile and other intermediately connected devices, you have much higher probability of winning users over. The next thing is plan ahead for scalability. Why fall into the ditch and then try to get out of it? Why not just plan ahead so that you never fall into one? So in other words, your application can be quite elastic. It can handle sudden spikes of load. Of course, you win users over straight away. So that's why the NoSQL is needed for developing the databases. Now here, NoSQL storage types. There are four types of NoSQL databases: column-oriented document store, key value store, and graph databases. Now I am discussing one by one. This is the example of the column family stores. The column family orient database store data as a column as opposed to row that is prominent in RDBMS. A relational database shows the data as two-dimensional tables comparing of rows and columns, but stores, retrieves, and process it one row at a time. Whereas a column-oriented database stores data as columns. A column family database organizes its data into rows and columns, and in its simplest form, a column family database can appear very similar to a relational database. However, the real power of a column family database lies in its denormalized approach to structuring sparse data. So now simply we can say that column family store is the collection of the columns. Like in this example, this is the table by name of a personal table, and in this table there are two column families. One is the personal data and another is the demographics. The personal data column family contains two columns. This is the name and addresses. In the same way, demographic data column family contains two columns, the birth date and genders. So column family stores is the collections of the column. Now, in the next is the document store. Document-oriented database. A document store allows the inserting, retrieving, and manipulating of semi-structured data. Most of the database available under this category use XML, JSON, BSON, or YAML with data access typically over HTTP protocol using RESTful API or over Apache Thrift protocol for cross-language interoperability. So as compared to RDBMS, the document themselves act as record. However, it is semi-structured as compared to rigid RDBMS. Like two record may have completely different set of fields or columns. The records may or may not adhere to a specified schema. For the matter, the database may not support a schema or validating a document against the schema at all. So document store database store the different type of data like in the XML format or like in the BSON format or a JSON format. And if we store the query like storing data about a human being, next we can store the query for another things like any store like any human being data. So this is store the data in different formats. Now next thing is the key value store. A key value store is very closely related to a document store. It allows the storage of a value against a key. Similar to a document store, there is no need for a schema to be enforced on a value. Unlike document store that can create a key when a new document is inserted, a key value store requires the key to be specified. Unlike a document store where the value can be indexed and queried, for a key value store, the value is opaque and as such the key must be known as to retrieve the value. So in the key value store we can say that key is generated by the hash functions and hash functions implement the key value. Like this is the name of the key and this is the value of the key. So in the key value store, the record is stored in the database by the key value. Now another thing is this is the engine types. So there are so many types of engine used in the NoSQL databases. Like this is the name of the databases and this is the technologies used corresponding by the databases. Like column oriented database use the Cassandra, Google data stores, HBase, and in the same way document store use the technology BaseX, Cassandra. In the same way key value store use the Amazon SimpleDB. In the same way graph database use to store the data the Neo4j technology. Like this graph database use the Neo4j technology for storing the data in the databases. Now in the next section, what is the graph databases? Because Neo4j works on the graph databases. So Neo4j is the graph databases. Firstly, I am describing what is the graph database. A graph is a connected network of nodes. Each node contains information about a specific entity and each connection specifies a relationship between entities. A graph is just a collection of vertices and edges, or in other words we can say a set of nodes and the relationship that connect them. Graphs represent entities as nodes and the way in which those entities relate to the world as relationship. So graph database represent a special category of NoSQL databases where relationships are represented as graph. There can be multiple links between two nodes in graph representing the multiple relationship that the two nodes share the relationship Represented may include social relationship between people, transport links between places, or a network topologies between connected systems. So simply we can say about a graph databases, graph contains the nodes and relationship, and each of nodes and relationship have the property to organize the graph databases. Now, a graph database stores data in a graph, the most generic of data structure capable of elegantly representing any kind of data in a highly accessible. A property graph is made up of nodes, relationship, and properties. So it contains nodes and relationship. So this is an example of the graph databases. In this example, there are three nodes. One is ID1, another is ID2, and another is ID3. So these are three nodes in this graph, and the arrow shows the relationship between nodes. So this node contains the three properties like ID, name, age. In the same way, node 2 contains the three property. In the same way, node 3 contains the three property. And these nodes are connected through arrows. So arrow is recognized as the relationship between the nodes. Relationship also have the property like node is the property of a relationship. So these nodes are connected with the relationship of nodes. In the same way, the node 1 and the node 3 is connected through the relationship label is member. So relationship always is the directional relationship. Now, in the another thing, nodes represented entity. It means every entity, each and every entity defined in the graph database as the nodes. Ages represent relationship. So relationship is organized in the graph database by the ages. So a relationship always has the direction, a label, and a start node and end node. Connection between data are explored. The ability to add a property to relationship is particularly useful for providing additional metadata for graph algorithm like faster for associative data sets. So graph databases provide the way using this we can access the data in the faster way, and this is the time consuming, optimal for searching social network data like on Facebook, Twitter. This is the time consuming. This provides the easy way for searching any data like searching on any friends on a Facebook. So this provides the easiest way and optimize the time. Now another thing is the query a graph with a traversal. A traversal means visiting each and every node of a graph. So traversing means simply to traverse each and every nodes of the graph. Traversal navigates a graph. It identifies paths which order nodes. A traversal is how you query a graph, navigating from starting node to related node according to an algorithm, finding answer to question like what music to my friends like that I don't yet own, or if this power supply goes down, what web services are affected. Now another thing is index lookup nodes or relationship. An index map from properties to either nodes or relationship. This is you want to find a specific node or a relationship according to a property it has. So then traversing the entire graph, use an index to perform a lookup for question like finding any record on the graph database like find the account for username master of a graph. Now this is a simple example of the graph databases. A, a graph databases contains the nodes and relationship Both nodes and relationship have the property for defining the graph databases. Now, this is the simple format of the indexes. Index apply on the nodes, properties, and relationship. Indexes are used in the graph databases by using uniquely identify any record from the graph databases. By using of the indexes, we can easily, in the efficient way, you will find the any data from the graph databases. Now, another thing is the what is the Neo4j? Neo4j is the graph databases developed by Neo technology, most popular graph databases, and implemented in Java. This is the open source. So in the simple, we can say about a Neo4j. Neo4j is the graph database. Neo4j is a commercial supported open source graph databases. It was designed and built from the ground up to be a reliable database. So optimize for graph structure instead of tables. So in that way, the Neo4j is used as the graph databases. So working with Neo4j, the application gets all the expressiveness of a graph with all the dependability like you expect out of the databases. So this is the simple format of the graph, Neo4j graph databases. A Neo4j contains the graph databases. Graph database organized through the indexes and graphs. A graph contains nodes and relationship. Indexes applied on three of them: relationship, nodes, and properties. Traversal simply the visiting of each and every node of the graph databases. So traversal contains the graph, paths, and algorithm. For traversing graph, there is need of an algorithm like BFS or DFS. Now, graph databases focus mainly on two things. These are the nodes and relationship. So, what is the node? The node is a fundamental unit that form a graph are nodes and relationship. Nodes are often used to represent entities, but depending on the domain, relationship may be used for that purpose as well. This is a simple diagrammatically representation of a node. Node can have relationship and have the properties to defining any node in the graph databases. Now another thing is the relationship. Relationship between nodes are a key part of a graph database. They allow for finding related data. Just like nodes, relationship can have properties. A relationship connects two nodes and is guaranteed to have valid start and end nodes. Like this is a simply diagrammatically representation of a relationship. Relationship have the start and end nodes, and relationship also have the type, what type of relationship established between the nodes, and relationship also have the properties. So as relationships are always directed, they can be viewed as outgoing or incoming. Like this is the start node and this is the end node. So for a start node, this relationship is the outgoing relationship, and for the end node, this relationship is the incoming relationship. This node have the self relationship. It means this node connected itself through any type of relationship. So relationships are equally well traversed in either direction. So there is no need to duplicate relationship in the opposite direction. While relationship always have a direction, you can ignore the direction where it is not useful in a application. Now, another thing is the Neo4j chain tools. So this describes how to configure the Neo4j in your system and how to deploy the program using the Neo4j. So how to install the Neo4j technology into your system? Neo4j can be embedded into your application run as standalone server or deployed on several machines to provide high availability. Like Neo4j development option, Neo4j have the two options on a single instance on a multiple instance. Neo4j is normally accessed as the standalone server either directly through a REST interface or through a language specific driver, or in the embedded mode, Neo4j can be embedded directly in a server application by including the appropriate Java library when programming. Now, what are the system requirements for configuring the Neo4j technology in your system? So this is the CPU requirement. The minimum requirement is the Intel 486 and recommended is this. As the memory requirement, minimum is the 1 GB and recommended is the 4 to 8 GB. Now, the system requirement of disk, the disk requirement minimum is the SI, EIDE and recommended is this SSD and SATA. In the same way, the file system requirement minimum ext3 and the recommended is the ext4 or JFS. Now, the system requirement Neo4j is Java based, so that's why you firstly you install in your system the latest Java version, at least 6 or latest version. The operating system requirement, the Neo4j can run on any operating like on a Linux or a Windows or in a Mac operating system. The JDK requirement, the Neo4j runtime is continuously tested and install the latest JDK version. Now, how to configure the Neo4j in your system? Firstly, you download the Neo4j technology from the site, and after downloading, extract this file. You can download this Neo4j technology from the site like neo4j.org, and after downloading, extract in your appropriate directory. After extracting this file, you can put in your directory as you like. Like after extracting, I have placed this Neo4j in the directory like USR local Neo4j community. I have already stored this community after downloading, and then how to run the Neo4j community. After putting the Neo4j community in your appropriate directory, then you can run the simply command on your terminal on like on a Ubuntu slash neo4j start. After executing this command from the root on the terminal, you have seen the following information, and after this showing this information, okay, you can check the Neo4j community running on the server localhost by the localhost 7474 URL, and you can put the URL like the browser and admin in both the URL show the information about the Neo4j community. I'm showing an example after discussing about this. Now this is the server information after the execution of Neo4j. After started the Neo4j, let me show how to start the Neo4j. Like I'm saying go to root and after going to root, then start your Neo4j community by going the Neo4j directory like cd usr local Neo4j community bin. After going to this directory, you simply execute the command start. This was the information about the Neo4j community is starting, and now this was the Neo4j server is started. You can see this on a browser, like just give the URL here, localhost 7474 port. This was the your Neo4j server is started, and you can see the another web admin portion here by executing by providing the URL like localhost 7474 admin web admin. This gives the information about administration portion of a Neo4j community. So I am describing about this admin portion of a Neo4j. So now this is the web administration. The Neo4j web administration is the primary user interface for Neo4j. With it you can monitor the Neo4j server, manipulate and browse data, interact with the database via various consoles, and view raw data management objects like firstly the dashboard. So dashboard give the information. The dashboard tab provide an overview of an running Neo4j instance. So within the dashboard you can manage your DB instance beside creating a new instance like restore, import a database from a Neo4j, export database and delete the database, open the Neo4j web admin interfaces, obtain the connection from this. And this is the entity chart. This contains the information about the databases, how many nodes in the graph database contains, and how many properties and how many relationship. Now, what information shows the entity chart? Entity chart contain the current information with the time about a nodes and relationship. Now another thing is the status monitoring. This is the status monitoring. This chart is a collection of status panel displaying current resource uses. Now another is this is the data tab. Using this you can create the nodes and the relationship like nodes and relationship, and you can establish the property using this, and using this you can show the information about the nodes and properties. Now console, the console tab give scripting access to the database via the Gremlin scripting engine, query access via Cipher, HTTP access via HTTP console. So in this you can execute the Cipher queries and the shell command. Now this using this you can create the indexes for nodes and relationship. And this tab simply give the information about the server information like where is the database directory and related information about databases. So this contain the information about this server. Now another things, the next point is the Java core APIs. So Using Java Core API, you can build your own data graph using the Java language. You can simply execute the Java codes for creating the graph databases. And so this give the information how to interact with graph databases using the Java code. So Neo4j Core API is an imperative Java API that exposes the graph primitive of nodes, relationship, and a property to the user when used for reads. The API is lazily evaluated, meaning that relationships are only traversed as and when the calling code demanded to the next node. Data is retrieved from the graph as quickly as the API caller can consume. So with the caller having the option to terminate the traversal at any point for writes, the core API provides transaction management capability to ensure atomic consistency. So using this, you can interact with the uh, Java code. You can create the graph databases. So now, what are the APIs used for creating the graph databases like nodes, relationship, and properties? So these things are created using the in Java APIs. Now, how can you connect the core API to the graph databases? So this is the simple uh, code for connecting the graph databases. So this is the simply path for connecting to the graph databases. Our graph databases is stored in the directory like user, local, Neo4j, community, and databases. So this is the path for databases, and this variable simply is the string variable contains this path for connecting to the database. Now this is a simple class contains the reference of connection of a graph databases, and this factory is provide the connection to the graph databases. So graph database factory method is used for connecting to the graph database of a Neo4j community. Now another thing is the how to define the relationship between the nodes. So this is simple declaration of a relationship. This is the simply enum types, and this implements the relationship type interface for defining the relationship between the nodes. So this simply declare the relationship. Now another thing is the transaction. Every code executed in the Java within a transaction class. All writes have to be performed in a transaction. This is conscious designing decision since we believe transaction democratization to be an important part of working with a real enterprise databases. Now, another thing is how to create the graph databases. So these are the simple declaration of a variable of type node, and relationship node is the class, and relationship is also the class. And the first node is the variable of type node, and this is used for creating the node, and relationship is variable of type relationship class, and this is and create for creating the relationship between the nodes and a relationship. Now this is simply the code for creating the nodes and relationship. So create node is the method and is executed by following the graph DB path which contain the connection to the databases, and this method is used for creating the node in the graph databases, and this method is used for setting the property to the node that has been created, like the property type is the message and the property value is the name. This is the name of the property and this is the value of the property. In the same way, the second node has been created executing this code. Now using this you can establish the connection between the nodes. Using this, you can establish the connection, relationship between the nodes. The like first node create the relationship to the second node, so this establishes the relationship from first node to the second node. The relationship type is the nodes, which we have already declared in the enum, and this set the property to the relationship. The type of the relationship is the message, and the value of the relationship is the brave Neo4j. Now this is a simple method for executing the information about the node and relationship. So the get property method is used for getting the information from the node and relationship. So this method is used for getting the information about a first node, and this is method is used for accessing information from the relationship. In the same way, this method is used for getting the information from the second node. Now, if you want to delete or remove the data from the graph database, so for that purpose, the following method is used for deleting the data from the graph databases. So, firstly, you delete the relationship before deleting the node of the graph databases. And so using this, you can delete the relationship, and using this, you can delete method, you can simply delete the nodes from the graph databases. So I'm showing an example how to create using a core API. Let me show an example like this. This is my simple example. I have already declared this code in this. Just open the Eclipse, and after opening the Eclipse, configure all the API from the Neo4j live directory, and like this. This is my project. Just go to the sorry. Just go to the build path and add external jars, and go to just Neo4j community. Now from the live directory, you select all the jar files, all the API, and then click on the OK button. After clicking the OK button, all the jar files are added to the Neo4j community, and after adding, you simply execute the following codes like this. This is a relationship type. These are the variable of for node and relationship, and this is simply the connection and creating the nodes and relationship. This create the nodes, and this establish the connection relationship between the nodes, and this is simply give the information about created nodes and relationship. So by executing this command, the nodes and relationship are created in the graph database like this. So ABC love DEF. This is simply a relationship I have already created using this command. Like ABC is the first node, DEF is the second node, and this establishes the love relationship between node ABC and DEF. It means ABC love to DEF. So that's enough for describing about Neo4j.
Thank you, Daljan.
Yes.
Thank you all for attending this webinar. If you have any queries, you can write us on our email ID that you already have. And we also do, consulting development and do training on Neo4j technology. So Daljan is our Java developer who is looking after database systems. Okay. You can browse our website for more information. That is www.attuneuniversity.com, and our main portal is found on attuneinfocom.com. Thank you very much all for attending this webinar. Thank you.